Hello, it is Mrs. Applegarth. This is Chapter 10, Section 3. We are going to be talking about areas of regular polygons. There's some definitions we have to nail down first. The first one is the center of a polygon. It is the center of circumscribed circle about a polygon. So if you were to draw a circle, so say we just have, we have this hexagon here. If we were to draw a circle around, the center of the polygon will be the center of the circle that is drawn around the polygon. The radius of a polygon is the radius of the circle. So think about where, here's our center. And you guys please do your best to draw this. And then where our center meets our circle, oh yeah, that's here to the vertice of our polygon. So this is the radius. So it's from the center to the vertice. The apothem, this guy is definitely like hyper-focus on this apothem right now. The apothem, isn't that a fun word? I love it, apothem. It is the perpendicular length from the center so it's going to be perpendicular, so it's going to create a 90-degree angle to the side of the polygon. So it kind of drops perpendicular to the side. So please note the difference between the apothem and the radius. The radius is center to the vertice. The apothem is center to perpendicular to the side. And then this guy, central angle. What's the idea of this? It's the angle with the vertex at the center of the polygon. Angle with vertex at the center of the polygon. Let me show you how that works here. So it is the central angle of a polygon, angle with the vertex at the center of the polygon. So from radius to radius, that will be your central angle. Okay, let's dive into this. What does all this mean? So back to like, Ms. Applegarth has nothing to do with areas of regular polygon. So please remember, some of you guys may be just waking up out of a coma. But the word regular, when you apply it to polygons, it doesn't mean like, oh, they're like an approachable polygons, like one of us. Regular means that all the sides are congruent. So all the sides are the same. So like a regular quadrilateral, that would be a square. So all the sides are the same. So we're talking about just regular polygons. So these are special just to this polygon. Okay, so we are going to find the measures of the angles of the triangle. So all these angles here. And the radius and apothem of the regular hexagon if one side measures 8 inches. Okay, so this is a regular hexagon. Hexagon means we have 6 sides. If you didn't know that, you could just count. But I'm going to write it down because I'm a visual learner. So, and hexagon will come up quite often. Okay, so we're going to pull this apart. So if we take this little triangle here, there's some things that we can figure out with it. So I'm going to pull it out of our little hexagon. Okay, so take your little triangle and pull it out here, just so that we have, it's gonna get a little crazy messy up in here. So if we were to continue throwing down some radiuses, some radii, we look and we say, well, how many circles? 1, 2, 2, 3, 4, 5, 6. So there are 6 central angles. And I have to divvy them up equally, because remember, this is a regular polygon. All the sides are the same, so all these central angles are going to be the same. Well, think about this. How many angles are in a complete trip around a shape? It's around a circle. How many angles? Oh, that's right. It's 360 degrees total. We're going to divvy up that 360 degrees amongst these 6 central angles. So that gives us an angle measure of 60 degrees for this top. Okay, and then let's look at something interesting here. So this side from the center to the vertice, that's the radius. Oh, it is also the same distance from this center to this vertice. So we can say that these two sides, this one and this one, are the same. And what we know about isosceles triangle is that the base angles across from the congruent sides are going to also be equal. So let's think about this logically. Some of you guys are like way ahead of me, like, I know what it is, Miss Africa, but let me just take us all there. If there are 180 degrees in all the angles in a triangle, 60 of those are devoted to this top angle. So that leaves us 120 to divvy up equally in the 2 other angles. Well, what's 120 divided by 2? Oh, that's 60. Uh-oh, Miss Albergard. This is an equal angular triangle. So this side has to be congruent to this side, has to be congruent to this side. Ho ho! So we have answered the question, find the measures of the angles, we did, of the triangle, and the radius, which we just did too. So the angles are 60, the radius is 8. Now we have to tackle the apothem. The apothem is that distance from the center to perpendicular to the side. So essentially what it does is it cuts this triangle in half. So what we are going to do is we're going to draw this little triangle out, and then separate him so we can see what and start fussing and not get too busy. Okay, so let's take this triangle here. It is half of this triangle. And so we know that this angle is 90. We know that this corner, this one right here, it's the same as this corner. He is 60 because we calculated him, this guy here. So that leaves us with this distance being 30. And watch out what happens here. So the apothem is this distance here, from here to here. Now check this out. I'm going to redraw this little triangle. Oh my God, darker. Okay. So here's this little triangle. We are pulling out this little triangle because we want to find the apothem. It's the distance from the center to perpendicular to the side. So let's see what items we can glean. If the whole thing is 8, what is half of 8? That's right, 4. So my short side here is 4. We know that the hypotenuse is 8. We could use 30, 60, 90 triangles to figure this out, or we can just see it's the same as this distance here. Oh yeah, that's 8, that's 8. Okay. So now we need to find this apothem. So in a 30, 60, 90 triangle, the short side is here. The hypotenuse is 2 times the short side, and the long side is your short side times the square root of 3. So aren't you glad we did all that special right triangles shenanigans last week? Because now we go, oh yeah, of course it's 4 root 3 Miss Applegarth. We did practice on it. So the apothem is 4 root 3. Okay, and we just go back and make sure we answer the question. Find the measure of the angles. We did there 60 of this little triangle. And the radius, which is from here to here, we did, it's 8. And the apothem, which is from here to here, and we found that is 4 root 3. Of the regular hexagon, if one side measures 8 inches. So we are only given the side, and we were able to find all that information. So incredible. Okay, next topic. So here we go. Area of a regular polygon. Remember, regular means that all sides are the same, and polygon is a shape. The area of a regular n-gon, so it could be any number of sides, with side length s, is half the product, which means times, the apothem A and the perimeter. So area equals, you guys are writing this down. Thank you so much for writing down. 1/2 little a stands for the apothem, times the perimeter. I'm going to give you one more little formula just for fun, so you have that in your pocket when you go to tackle these. The perimeter is going to be equal to the number of sides you have, n, times the side length, s. So perimeter, we usually think, oh yeah, let's add all the sides together. Well, all of our sides are equal, so we don't have to do, 4 plus 4 plus 4 plus 4 plus 4 plus 4. We are going to do 4 times the number, so if it's the side length is 4 and we have a hexagon, we are just going to go 4 times 6. So I'm adding this perimeter formula because I'm going to use that instead of the plus method to find the perimeter. All right, so let's go ahead and do this. Find the area and perimeter of a regular hexagon with a side of 8 inches. Oh, we just did this. How fun. Okay, so let's throw down the center. So draw your hexagon. I draw my hexagon. I got a line on the top, a line on the bottom, and then 2 diagonal lines that kind of meet in the center, just in case you're wondering how to draw polygons with the hexagon. Okay, we know from here to here is 8. We know from here, just this little snippet is 4. And we know that the apothem is 4 root 3 because we did it here. Just in case you fell asleep between this page and this page. We calculated the apothem is 4 root 3. So now we have to find the perimeter, and then we can use the area formula. So the perimeter is 8 plus 8 plus 8 plus 8 plus 8, or the perimeter is the number of sides we have, 6, because it's a hexagon, times the side length, 8. 6 times 8 is 48. Okay, so let's put it together. Area is equal to 1/2 times the apothem times 48. Okay, and remember, we deal with all of our whole numbers together, and then if we don't have any other roots, this root 3 just hangs on to it. So I'm going to do 1/2 of 4 is 2. 2 times 48 is 96. So I'm going to say this is 96√3 inches squared. All right, let's see what happens when we get a regular pentagon. It has a side length of 11.6 and an apothem of 8. Oh, aren't they sweet gems? They gave us the apothem so we don't have to use trigonometry to find it. But guess what's coming up in your future? Okay, so let's put the formula is 1/2 apothem times the perimeter. So we know that the apothem is 8. And I'm going to throw the perimeter calculation just right in here. There are 5 sides, and they are all 11.6. I don't have any square roots, so I am thrilled. I am going to get my calculator out to this, though. So we got 1/2 of 8 is 4 times 5 times 11.6. And we got 232 centimeters squared. Easy. It's easy to use the formula when they give stuff and you don't have to figure it out. If the side of a regular polygon is reduced to 1/2 its length, how does the perimeter change? Explain. Okay, so let's do a little test. We'll make these, let's go 10. And then we'll make this one 1/2 of that, 5. So the perimeter of our first one is 10 times 5, because there's 5 of the 10s. We add them all up, and that's 50. And then the perimeter of our smaller guy is 5 times 5, which is 25. So how does the perimeter change when we cut the side in half? Oh. When we cut the side in half, the perimeter is cut in half. Interesting. Okay. Let's find the area of an equilateral triangle. The apothem, so think about what an apothem is. From the center, so if I were to draw, it's interesting to see this. If I were to draw a circle, the center would be the center of the circle that is circumscribed about the triangle. So the apothem is 14. And we have an equilateral triangle, so that means all the angles are 60 degrees. So let's just take a peek at this real quick. So this up here is 60 degrees. This corner is 1/2 of, so the whole thing is 60. So this guy is 30. What? Crazy. And you're like, Ms. Algar, why are you doing that? So if we want to find the area, think about the area formula. Area is equal to 1/2 the apothem times the perimeter. To find the perimeter, I'm going to need the side length. So I'm in a 30, 60, 90 triangle from this equilateral triangle to find the side length. So fun. Okay, so if I know my short side, like take a peek at this 30, 60, 90 triangle. My short side is 14. And I want the long side, so the long side is going to be 14 root 3. And that goes from here to here. I'm going to have to double it to get the real side. So 14 times 14 root 3 times 2 is 28 root 3. So the side length is 28 times the square root of 3. So we know that the apothem is 14. We know that the perimeter is going to be 28 root 3 times how many sides we have? 3 sides. Oh, this is so fun. Okay. So I'm going to do all my whole numbers together, and this root 3 has nobody to hang out with, so he's going to chill on the end. So we got half of 14 is 7 times 28 times 3, 588. So that's all the whole numbers together, and then a root 3 is just going to chill on the end. Centimeters square. How fun was that? Equilateral triangle. Ooh, I'm glad we did that review. Okay, let's check out this square. This square has a radius, and remember the radius goes from the center to the corner of 4 inches. So think about a square. This is, each one of these guys is 90 degrees. This cuts the 90 degree in half. So each half of this is 45 degrees. We're going to create a little 45, 45, 90 triangle here. We know that the hypotenuse of this little triangle is 4. And because we know 45, 45, 90, we can say that the side length is, so the rule is the hypotenuse of a 45, 45, 90 triangle is your side times root 2. Well, we have the hypotenuse. We want the apothem. We'll call it A. So we have to divide by root 2. So the apothem, and we want to find the area of the square, so the area is 1/2 the apothem times the perimeter. So we know that the apothem is 4 over root 2. I know that this guy is 4 over root 2. Is it upsetting that we have the root 2, children? So let's go ahead. We'll rationalize the denominator and replace 4 over root 2 with something more rational. Heaven forbid we irrationally go about our business. Okay, so we times the top and the bottom by root 2. We get 4 root 2 over 2. And then 4 over 2 reduces to root 2. Okay, so I'm going to replace this guy with 2 root 2. That way we don't have any fractions. Okay, so I know that the apothem is 2 root 2. And we need to find the perimeter. There are 4 sides. And each side is, it's not 2 root 2. It's 2 root 2s. Is that enough 2 root 2s in your life? So 2 root 2 plus 2 root 2 is a 4 root 2s. Okay. 4 root 2. So we just double the number. When you're doing this calculation, you just double the number in the front. So if half of it is 2 root 2, the whole of it is 4 root 2. All right, and let's combine all the whole numbers together. Half of 2 is 1. 1 times 4 is 4. 4 times 4 is 16. Oh, and then we got some roots to play in the game. I love it. So we got the root 2 and the root 2. I like to think of the square root as like a magical sucking power. It takes all the roots and sucks it up. When you're doing multiply and divide, it can suck it up underneath one root. Root 2, 2 times 2 is 4. And the square root of 4 is 2. So my area is equal to 32 inches squared. Okay, The concept is not difficult. The keeping track of the little details. If that is not your jam, just make sure you've got your squeezy focus stress ball with you, and you're keeping track of your little pieces. Go slow and make sure you're in the right headspace for this, because you cannot rush through this or you're going to get it. There's so many little pieces that need to work together to get to the end. All right, we'll skip constructions for another day. That'll be just fun if you're in class. Okay, that is all for our lesson today. Make sure you go back, do the practice assignment that I've assigned. When you're finished with that, or if you get stuck with that, come back here, check out, make sure you have the correct answers. I tried to rush through this, and there were a couple problems I had to redo a couple times. So make sure you take your time, get in a good place. This is great practice, not only for 30, 60, 90, and 45, 45, 90, but keeping track of how square roots and stuff work together. All right, thank you.